Welcome to all of you who have joined us for today's webinar, which is to introduce you to a joint initiative between Energy Networks Australia and AEMO called the Open Energy Networks Project. This project aims at identifying the best way to transition our energy system to a two-way grid that enables better integration of distributed energy resources and allowing better outcomes for all customers. Presenting to you today are Chris Cormack, who is the Energy Market Leader at AEMO, and myself, Dr. Stuart Johnston, who is General Manager, Network Transformation at Energy Networks Australia. I do apologise, there might be some slight aspects to the audio at different times. We've just had a few issues with technical issues with our phones today, so please just note that. The purpose of today's webinar is to provide you a bit of an overview of the Open Energy Networks project and the consultation paper in general, and also to introduce the idea that we actually want to consult with all of you out there around the paper, which we actually launched on the 15th of June, and highlight how you can engage on that project before the closing date on the 3rd of August at 5 p.m. We're particularly looking for, obviously, by that closing date, we're looking for written submissions, particularly around those different strawman models that we've actually put in the paper. But we're also, the whole idea is that there's other ways of actually engaging with us during this process. So today is probably the beginning of that, but we are open to doing briefing sessions and meetings to discuss some of those issues around that, and we're also going to have some major workshops held later in July to actually try and engage with those. They'll be held one in Sydney, one in Melbourne, and one in Perth. And as we actually nail those down in terms of dates, we'll actually be sending that out through our website, and also to the distribution list to actually make people aware of those and how they can actually register for them. But if people want to talk to us individually, the whole idea is if we're actually we are going to be trying to visit different parts of the country as part of this consultation, and we'll actually again be giving those dates out. And so if we can actually combine those when we're actually in Perth or we're in Brisbane, etc., we'll try and do all those consultations in one go and briefing sessions. So going into what we're trying to do with this piece of work, the first one is actually is around the project aims. This piece of work is to try and establish and achieve acceptance of why the system. We need to actually optimise distributed energy resources in the system, to identify the key functionalities required and when they'll be required, and how those functionalities may need to evolve over time, to try and identify and specify the functional requirements, particularly for the DSO AEMO interface, around the visibility of that DER. So how can we actually make that visible to AEMO to actually utilise and manage for the whole of the system? And then how we can actually deliver that functionality. So looking at different models or model frameworks that address some of those challenges we've actually got, but also allow access to those different markets and the requirements so we can actually manage those things through. The other aspect I'll say today, if people have actually got any questions around what we're trying to do here, there's actually the box in the bottom there. Please actually write those questions into the bottom of into that box, and at the end of the presentation, what we'll do is come back to try and answer some of those questions as best we can. If we run out of time, the whole idea is we'll try and come back to those at a later date, or as I said before, we can try and engage with you separately outside of this process. In terms of the actual purpose of the consultation paper, it is actually to lay that foundations of establishment of both that functionality and trying to identify, getting an agreed framework to facilitate that optimisation of active DER going forward. Now, we've actually put in this document a couple of different strawman models, but they are not the final version. They're just ways of actually delivering that functionality at the moment. So that's just ways we actually looked at how that functionality could be identified, and the purpose of this consultation paper is to work with all of you to actually identify are they the right models? Are there other options out there? Do we need to tweak those models we've actually got there at the moment? So they're all just different thoughts and processes we actually like to actually engage with you around this. And get you to help us co-design those frameworks which we'd like to test in the next stage of this work. So the key questions we'd like all stakeholders to consider in looking at this paper is, what are the new capabilities, functions and roles that will be required to coordinate and optimise the value of customer DER investments whilst maintaining security and reliability across the NEM? Now, that question is actually for the NEM, but this is also pertinent for Western Australia, for the WEM, and also for any other network out there who's just running microgrids as well, because the whole principles around what we do here will also be utilised for those systems as well, or could be utilised for those systems as well. In terms of the project deliverables, obviously we've got the consultation paper out there at the moment, which is looking at trying to get that agreement on the functionality required and potential model frameworks that we would like to test that will enable and deliver that functionality going forward. Once we've actually got that, so it's actually to try and to highlight those to actually utilise in the next phase of work. There's also the first deliverable that will actually come out once we actually do that is later this year. Is the first aspect is around what are establish what are the key least regret actions that will need to be actioned immediately under all model frameworks to manage DER optimisation issues. So there are some key issues that we need to do that will be agreed upon with key stakeholders, that no matter which optional model or framework we actually utilise to deliver this going forward, these things need to be done now to actually help us manage all the integration of DER and increasing levels of DER coming into the system in a manageable manner. The second, obviously, deliverable will come through next year after we've actually identified those frameworks. We've tested those frameworks by mapping the architecture and then doing some cost-benefit analysis around that. Is around the development of a final paper, which will identify the framework which actually comes through all that analysis in the best way, and how that framework will actually be delivered. This last slide, this slide gives an overview of how the system is transforming and the issues that need to be managed going forward. So obviously people are aware that Australia's electricity landscape is transforming very, very quickly as customers embrace new technologies such as rooftop solar and storage, but also we're going to have more and more electric vehicles coming into the system, and also the way people manage their energy use will also change going forward as well. So how they actually interact with that and how they utilise that energy will actually change. However, with all that increasing rapid rate of growth, there's issues around the behaviour of that solar and storage on the system, which is going to be hard to anticipate in terms of when it's going to be used, how it's going to be utilised, and so we need to actually have a bit of a better handle on in terms of how that's actually done. There's also issues on the system itself in terms of the networks. Obviously, the systems were designed initially to have a one-way flow down to the household, and now with all that energy coming in at the household level or the bottom end of the system, there's going to be that power flow is going to be multi-directional going forward. Not only back all the way up to the wholesale level, but if we actually design this properly, there's going to be movement across the local level to actually allow peer-to-peer things like peer-to-peer trading, demand-side services, which could actually be used by the network at the wholesale level, but also at the distribution level as well. However, if some of those issues around that extra increase of energy or system into the system, those challenges, they can actually potentially exceed network limits if they're not managed properly. So we need to actually ensure that those issues are actually managed appropriately going forward. I'll just hand over to Chris for the next section.
Thanks, Stuart. So, it's probably no surprise to anyone that the growth of DER is increasing. We've seen it really since the early days of feed-in tariffs across different state jurisdictions in Australia, that the growth of solar PV installations has continued to increase, and AEMO is continuing to forecast increases in the uptake of solar and increasingly now storage to increase, kind of on an almost linear basis out till 2035. Sorry about that. I'll try and be a bit clearer. So this obviously then leads to a number of integration challenges. These will be on both a system and a distribution network level. Our initial analysis suggests that the first thing that is changing is the demand profile. So we run the NEM, the system, based on certain load profiles. As Stuart mentioned, the increasing two-way flow on the system really is making the demand profiles much different to what they used to be. We need to kind of review our load modelling and make changes appropriately to the way that we manage the system. We can see that DER generation can exceed secure system limits from time to time. There's some analysis that we've done which really indicates that that time, especially in somewhere like South Australia, is growing closer. It's probably in the 2024 to 2026 range that we see that there is going to be times, specifically kind of spring, autumn times on weekends, where the amount of solar that is on the network will exceed the Hayward interconnector capacity. That obviously is with kind of no other changes to the way that we operate, and there might be some other options in terms of how we get, how we focus on that problem. But one of the other issues is response to disturbances. We've already seen one or two instances where large amounts of solar might have tripped at any one time, and we're investigating those. We need to understand how especially inverters react to disturbances within our network and our systems. Emergency frequency control mechanisms are now under review. One of the issues around load shedding at times of high frequency is that if there are large amounts of DER in the network, that obviously may not have the effect or the required effect on frequency to remediate any of those issues. And at a very basic level, AEMO would like visibility of DER for forecasting and planning purposes. We've obviously got models that look at trying to determine how solar and increasingly now storage will be used within the network on a forward-looking medium to long-term basis, but also increasingly on a short-term basis. And these are constantly under review, and we're needing to find new sources of data. One of the things that's happening in that space is the DER register, which I believe should be released as a draft by the AMC today, the way forward on that. There's also distribution network challenges. So some of the issues around the distribution network are really focused on voltages and power quality. Some things that AEMO worries about at the transmission level as well, but these will be specific to the distribution network. We're already starting to see that in places like South Australia with AS4777 settings that will basically mean that the inverters will trip when there are high voltages within the distribution network. That's anecdotally an increasing concern amongst solar owners in different parts of the networks. And there's also issues at the distribution level around reverse power flows. I'll move on to the next slide. So that brings us to the need for integration. We can see some benefits in efficiencies to the whole system, improved system utilisation. So obviously, you know, there are a number of investments made to networks and to transmission that could be better utilised if DER is optimised. And you know, if the right incentives are put in place to enable customers to interact with the grid, then we see that these efficiencies can lead to also value being exchanged with customers, or you know, incentives are being paid to customers to get them to basically allow their solar and batteries to be used not only for their own optimisation, but also for optimisation of the network or the system when required. So this value really will be seen through reduced requirements to build additional generation capacity. So, you know, we're seeing that the distribution network at certain times will be providing, you know, 40 to 50% of, say, South Australia's generation capacity. We're seeing that, you know, network solutions will, if we optimise, then basically we will not need to invest as much in network solutions to deal with the changes in demand. And we also can see the need to provide better customers provide customers with better value for DER investments. So right now, it's probably difficult for DER owners to access the wholesale market, to access demand management services, which batteries and solar can provide. And there's also the potential to establish local markets. So Stuart mentioned peer-to-peer markets, and you know, we can also see that network congestion might be a future focus for DER market as well. I'll pass back to Stuart.
Thanks, Chris. This next slide illustrates that while batteries added to the solar PV systems, unless managed properly, they can cause their own issues due to the rapid ramp rates and potentially high output of power going forward. This comes from that the Salisbury battery trial in South Australia, and which illustrates that rapid charging of batteries in preparation for a storm event to ensure availability of backup power. However, the top spike there was actually shows that the resultant demand nearly breached the local demand network capacity during that time. The bottom spike on this also showed that if batteries were also all discharged together in response to, say, I think something like a price signal, again, local network capacity could also be exceeded. It's still showing that batteries can actually can be a wonderful tool for this, but we need to actually manage those batteries or that discharge those batteries in a way that we don't end up with spikes which exceed the limits for the networks. And so I suppose what we're trying to do here is actually optimise that across the board, and we'll talk about those issues to actually make sure that we can orchestrate or optimise those to manage that we don't get those spikes which will actually exceed local constraints. This next slide goes through the value release. Some of the work that we actually did with the transformation roadmap, which was the work that preceded this, and where this piece of work comes from around DR optimization, shows that if we actually do this work, it can actually lower network charges by about 30% compared to 2016, and deliver those annual savings of around $414 in average of household electricity bills, while avoiding about 1.4 million in network investment going forward. We also, some of the modelling that's been extrapolated from this from CSIRO's since then was also, it's only very rough, but it was saying that if we actually do this properly in terms of optimisation, then by 2050, about 50% of the value of the NEM will actually come from from the DER going forward and the use of that DER within the system. However, actually to deliver that, it can't actually be done in one stage. So the whole idea is we need to look through this in terms of what are the strategies we've got more around to deal with what the issues we have at the moment around the passive energy exports going through. So we've got work around AS4777, traditional network upgrades, tariff reform, export limits, and things like that that we've got tools there to manage at the moment. However, if we want to take this forward, we need to actually add more dynamic strategies. Creating new network models and allowing a monitoring of the system in a better way to actually, so we can actually manage some system constraints that are going through. Looking at dynamic export limits and also having smart DER so we can actually utilise that or manage that in a better way. But if we want to get to the last stage, is the whole idea is actually making that available. So how can we actually optimise that DER going forward so it actually be utilised into the market platforms and create those market platforms? How can actually go in there and actually participate at the wholesale market or local markets in a better way, which will actually allow for network savings going forward. In terms of the aspects we're trying to look at as part of this program, is around things like is all the things in red. So this piece of work is looking at advanced planning, what we need to do around advanced operations, the dynamic strategies that will actually be needed to actually enable that, and market platforms to go through that. But also things that actually support underneath that. So what are those? What's data is going to need to be utilised? The DER data, customer data, GIS. How was that going to be utilised? Network models, updating those around the HV for network, LV networks, demand profiles, but also then what data do we actually need to provide back to across the system as well from a networks perspective in real time, SCADA data, LV monitoring, issues around constraints, information from smart meters going forward, and smart DER. So these are things that will have to be actually looked at and as part of any of the models we actually look at in terms of going forward. I'll flip back to Chris now to actually talk about the current framework that we're actually working in under at the moment, and then take us forward into some of the models we've actually just outlined within this paper.
Yeah, so this is a fairly simplified version of the way that DER really works at the moment. So, you know, what we are seeing is that DER, if it is activated, really sits behind the retailer. We can see that via our DSP information portal that there is increasing amounts of kind of activated battery and load that is in retailers' portfolios, but really there is no direct access into the wholesale markets, and there's really no consideration given to the distribution network. So if we move forward to some of the proposed frameworks that we have put into the paper. The first thing we wanted to do was to have a look at what the new, probably existing and new functions might need to look like in the event that a distribution level market was required. Now, I noticed there was a question on the text box, basically, asking if we had made an assumption whether a distribution level market was required. I mean, I think that's certainly what we are assuming. Having said that, we still need to prove that the costs or the benefits outweigh the costs, rather. But assuming that we are going to go forward with something that looks similar to a distribution level market, we thought we'd need to analyse the functions that would be required. So the first one, if I look at the top left box, is the DER register. So that's the subject of AMC rule changes at the moment. And we see it operating similar to the way that standing data operates in MSATs at the moment. It might be a separate database, but we're keen to get some visibility on what's out there. And I think that's a key building block to any future distribution level market. In terms of maybe I'll go back to now some of the DSP functions, DNSP functions rather. Currently, when you install DER, there is a connection process, and the distributor basically then inputs your DER into kind of a system monitoring and planning platform. In the future, we imagine that this will then feed into the development of distribution level constraints. So how that is going to work and what those constraints need to look like is the subject of some reviews at the moment. And I think there are a number of DNSP level research projects. ARENA's got a funding round that's focused on both projects and research papers that are trying to delve into network hosting capacity. So, the way in which that will work is still an open question. But I think we can certainly see, at least in theory, that there will be issues to do with distribution level constraints, especially when you start to get reasonably large amounts of activated DER, so solar and batteries operating as VPPs or something similar in the future. So we've already seen quite a number of announcements about VPPs going forward. We still haven't seen a large amount in practice, but it's only a matter of time before these things happen. In terms of the way some other functions, we see forecasting being important. The way in which any energy system operates, at either a transmission or distribution or even a local household level, is actually going to hinge quite importantly on forecasting. So everyone probably needs an understanding of how much energy needs to be consumed to optimize the way that they use the battery. And it's going to be no different at the distribution level. We can see that also once you get these constraints, you've got DER bidding into both the wholesale and potentially a distribution network services market. There will be a need to optimize at the distribution level. So really what we've made is an assumption that distribution level bids should be aggregated and then optimized before they go into a wholesale distribution optimization. So that might be at the transmission connection point, could be at a zone level. All of these questions would need to be answered as we move into a development phase for any of this. Now, that's not to say that there aren't other models for how this might work, and I know that there are people out there who can see the future being optimization really at the device or edge of grid. And if there are those out there who have those kind of ideas or models in mind, we would certainly welcome your feedback through this consultation process on how that might work. But I think what we're aiming for here is an optimization and dispatch, which kind of mirrors to some degree what happens at a transmission level, with the need to obviously develop distribution level constraints and an optimization process. Moving on to some of the principles that we put forward for framework design. This slide seems to have gone a bit skew-if, but simplicity, transparency, adaptability of the system to new technologies is the first one. Affordability is obviously going to be important, and it's increasingly important as we go forward. What we want to ensure is optimal customer outcomes, and there's probably more than one cohort of customers that we need to keep in mind when we're thinking about all of this. Obviously, there are those who've made investments in DER, but there are also those equally who either can't or won't invest in DER that we need to keep in mind. We want to minimise the duplication of functionality where possible and utilise existing governance structures. So, we probably don't want to invent any more red tape than we've already got. We want to promote competition in the provision and aggregation of DER. We want to be relatively neutral to technology, and we want to reduce barriers to entry. We want to promote information transparency, price signals that encourage efficient investment. And again, this is all should be done at the lowest cost. So all high-minded principles, but in terms of some of the options that we're putting forward in the paper around the frameworks, the first option is what we've called the single integrated platform. So really this is AEMO taking the role of the both wholesale and distribution level dispatcher of DER and of transmission level generation, with the DNSP playing the role of really managing network constraints and ensuring that all of the VPP or other DER type bids that might come into this platform are taking into account network constraints. We would then feed that into our NEMD dispatch, and we would need to still develop ways that would interface with our current dispatch operation. But I guess the benefit here is that there's only one platform. The DNSPs still manage their networks and therefore the network constraints. One of the issues obviously is that there would be an issue if there were any bids that were not able to make it through either the network constraint or the NEMD dispatch process, and there may need to be iterations of this bidding function or the bidding process, which might slow things down. But obviously we would need to work through how the interface worked and some of the rules around that. And that's probably going to be the focus of any future analysis of how these things work. In terms of option 2, so what we're looking at here is really the DNSP as the DSO. We see that this model basically allows for the aggregation of all bids at the distribution level, there to be though any network constraints that would be in operation would be able to be invoked at the distribution level, and basically any distribution level bids could then be optimized or iterated before it became a bid that would be, or an aggregated set of bids that would come into the NEMD dispatch engine. So, I mean, again, there could be issues regarding where those aggregated distribution level bids might not be optimized, not meet the NEMD optimization, and iterations might have to occur. But I guess in this model, you've got the DNSP aggregating everything at the distribution level to at least optimize that. And obviously that, depending on how the network constraint model is actually put together, and given the often real-time nature of constraint calculations at the distribution level, there would be the ability for the DNSP to to in real time monitor and constrain where required. Option 3 is basically an independent party operating as the DSO. So I guess similar in part to the first model, but having an independent body really then aggregate the bids at the distribution level, interface with the DNSP around the network constraints, and then feed those aggregated bids up to AEMO, who would then dispatch. So again, there's going to be issues around how these would be optimized, and the process around that in terms of iterations of bids, especially where either distribution or transmission level constraints are binding. But I guess the alternative, and one of the models that we had looked at was basically to allow DER to access the wholesale market separately to kind of an optimization at the distribution network level, and we can see that there are issues associated with that mean that kind of model is not ideal. And look, AEMO is going to release a paper on some of the studies at an international level that have looked at that, and DSO more generally in terms of some of the research and some of the early stage activity that's happening in that area. Short plug for that particular thing, which we will be looking to publish early next week. I'll pass back over to Stuart.
All right. So the paper, so what Chris has just finished there is basically the aspects that are actually covered within this paper, and what we want to consult with you directly on going forward, so we can actually get those when we actually start testing models. We've actually got your feedback in terms of co-designing which actual models or frameworks we actually want to take to the next stage. I suppose what I wanted to show or talk through now is just quickly go through what we intend to actually do with those models, so that once we've actually framed those up through this consultation phase. The first part is around, we'll need to actually then look at the DSO architectures and why they're so important for that transition process. Obviously, there is a considerable uncertainty around the future roles and responsibilities. There are issues around commercial principles, regulatory frameworks, and market arrangements which are subject to change. There are going to be new actors and disruptors who will play increasing roles, so we need to make sure that they're identified within these processes. But we also need to ensure that there's a consistent approach is taken to understanding how those various futures may or might manifest themselves going forward. So it is going to be crucial to define what those potential futures might look like. Obviously, there's going to be variance, and any of those different futures could have different levels of change that might be required, both from a technical perspective, a commercial perspective, both at a large scale, but also with the owner of the DER themselves, all the way down to the household level, and also the regulatory framework that actually sit with that. So we need to be able to look and test each of those different areas, and by doing this through case studies or use cases, so we can actually go through and actually test different aspects in terms of how each of those models may actually deliver that use case, and who or what are the different actors that may need to actually talk to each other and actually need, and what sort of information they'll need, and what time frames, etc., to actually make those models actually work under those different use cases. And so what we are looking at doing is that first level modelling that we'll actually do with each of the agreed models we actually agreed to take forward will be around modelling those against the SGAM models. SGAM architecture, which is that smart grid architecture model that's actually been utilised in Europe. So we have done, to get us to where we are at the moment, we have done a scan of international work that's been done in this area, particularly in Europe, the United States, and the UK at the moment, through another project which is very similar to what we're doing here, which is the Open Networks a project out of the UK, which is being run in conjunction with Ofgem, Energy Networks Association of the UK, and all of the other key stakeholders in that area. The whole idea of this is the SGAM model can actually be a bottom-up or a top-down in terms of how it actually approaches modelling use cases. We're suggesting we'll actually do this from a top-down approach. So the whole idea is defining that use case and then looking at in terms of what the functionality or business layer we want to do, and actually driving that down through those layers, which is obviously what the function is that comes out in terms of the business. What is the information that needs to go between all the different actors that have actually been identified as a part of that, how they will actually need to communicate to each other, and what are the components or requirements across that system in terms of how they're actually then to be able to work together. The whole idea of that is once we've actually got those and actually mapped out that architecture across the board, we can then do proper cost-benefit analysis against those models to actually work out what will that mean in terms of delivering the model. So it could be that it becomes cost prohibitive to actually go down a certain way, or it could be but the whole idea is to actually do this properly with analysis and utilise the models which we actually develop with yourselves to actually go down that path. So what are our next steps? What I want to basically go through is, obviously we've got the consultation open for 8 weeks. That closes on the 3rd of August. What we want to do in that process between now and the end of that time frame is engage with as many of you as possible, and also get feedbacks and submissions from you in regards to this paper, so we can help us design and frame those models which we want to take into the next phase of work. We are going to be establishing an industry reference group as part of this, and we're going to be doing that in July to help us in that next phase to actually bounce ideas off and thoughts processes of. That will be hopefully be taking people from or representatives out of both customer groups and representing customer functionality, as well as from regulators like the AER, the AEMC, and also other aspects of the industry, from gentailers to retailers to potentially tech providers, and the whole idea is to utilise those people to bounce things off. However, to make sure that we actually do this with a wider stakeholder group, we'll also be running at different times across this work program as it goes forward, not only in this consultation phase, but through the rest of the program, will be to actually run workshops on specific issues. Some of those might be quite close and related to a certain issue. Others will be very, very wide and open to all stakeholders to actually be involved in. We're looking at trying to kick off that phase 2 probably at the beginning of, at the end of this consultation phase, but getting that in train so we can actually go straight into that as August goes ahead, and incorporating all the feedback we've got from consultation into actually finalising those models over August, so we can then start testing those in late August and September, in actually working with the stakeholders to actually try and identify who needs all the different components around those new models. So we'll actually be running workshops in that time frame to actually test each of those different models we take forward. The first deliverable, so along with that, we'll also be a model identifying what are the key no-regret actions required to manage the orchestration issues. So things that just have to be done now to actually manage some of the key issues we go forward with. Again, that will be done in consultation with all the key stakeholders that are out there, so that will be done through this consultation, and then mapping what are the key functionalities that across all the different models we have that are actually would be common to all of them at the bottom end of the stage to actually enable it to actually happen. Once we've actually nailed down that, we'll then be doing the clear testing of those models against those use cases between October and February next year, and going through all those different aspects, and then bringing back the results of that to all of the stakeholders in late February, early March next year. And so to make people aware of what's come from that. Once we've got those, we'll then take those assessments and actually get CSI, or we're working with CSIRO to actually do like an independent cost-benefit analysis on each of those different models. The outcome of which will then be utilised to help us select the optimal model based on that to actually then help us draft the final DSO paper, or the Open Energy Networks paper that will come from that. We'll then go back out to consultation around that final paper, hopefully around mid-2019, with the idea that we'll actually finalise and deliver that final paper around September next year. That's just the same sort of aspect as a bit of a more of a planner, so it gives you a bit of an idea of where we're going to be doing things when. Obviously, the whole idea, again, those diagrams at the bottom is that we can't do this by ourselves. We need you to help us actually design this and actually be part of that process. The same as we did for the roadmap process. We want to actually co-design and work with you to actually get the best outcomes for this to take it forward. So the whole idea is we want to engage with as many people and parties as possible and get your feedback feeding into this piece of work. So that's the end of the formal presentation, and if there's my contact details at the bottom there, and also my email address. We are looking at, we're actually going to be setting up a separate, like a website for both AEMO and Energy Networks Australia which is around this piece of work, and it'll actually then, it'll also have when we're going to have workshops, how you can contact us, how you can actually get things, anything we publish or outcomes of workshops will actually go onto that site. We're only just building that at the moment, so that's why I was saying anything in the short term comes to myself, so it's just one funnel, but then once we've got that, we'll actually have a proper portal for you to go through. We hope to have that up probably in the next week and a half, before the major workshops we hold anyway going forward in July. I think there are a number of questions that have actually been asked of us during the workshop. During this webinar. What we'll do is we'll probably go back to the beginning of those and actually try to start working through some of those. Obviously, we're not going to be actually able to address all of them today, but what I'll try to do is either we'll try and actually answer those questions and actually publish that on our website so people can actually have a look at that. Or if we have a delay in getting those back to you in terms of actually answering those questions, then the idea would be to obviously come back and contact us and actually talk to us directly about any issues or things or you'd want to do or how you can actually work with us going forward. So I'll go back to right to the beginning of the presentation and go through some of those questions. There was one question right at the beginning around the DSO itself, and they actually looked at it in terms of the Urban Dictionary on this. Our issue around DSO is more around the optimisation. So we've actually got a definition within the paper, which actually talks about this. So that's probably what how we've actually identified it within our paper. So we've actually looked at it as distribution system operator. This term has been used to refer to the functions of distribution level coordination and optimization of multiple DER aggregators in multiple markets operating at the distribution level. So that's the term we've used for DSO for this paper and how we actually explain it through for everything we talk about. I know there are other people who've got different definitions on that. and it may have different connotations for others, but for us, we want to introduce it in terms of having a commonality around that terminology going forward, and that's how we've defined it for our piece of work. And even through this consultation, again, we could probably modify that slightly, but the whole idea is to we work with stakeholders, but the whole idea, that's what we're trying to achieve with this going forward. The next question that came through was, is there a model or scenario where we limit small-scale rooftop DER and focus instead on larger scale? I suppose what we're trying to do here is actually, how can we actually facilitate all DER coming into the system, both at the small scale and large scale, and how can we actually utilise and optimise that in the best manner? The idea of the models itself is to actually, then how we actually to utilise that DER in the best possible manner. So we're not actually trying to limit one over the other. The whole idea is to try and maximise the value of any DER that's been connected to the system. I might get Chris to talk to the next one, which was, how can AEMO achieve visibility of DER? How many sides are we talking about?
Yeah, I mean, just on the last one briefly, what we're seeing is that small scale and large scale DER, or small scale and large scale solar, is going to be installed, and there's different drivers for each of those, I guess, investment opportunities. But you know, we're anticipating that the small scale will continue to increase. I mean, as will the large scale. So I mean, some of the large scale stuff is addressed, or will be addressed more in our integrated system plan, which is due to be released in the next month or so. But you know, this is an attempt by AEMO and by the ENA to focus on kind of the small scale, which has probably been, you know, hasn't got as much attention as the large scale has, potentially. In terms of visibility of the DER, you know, what we're really trying to do there is to get the DER register operational. So that really will be solar, batteries, and potentially other sources of DER, although I think that's still the subject of the DER register consultation. And you know, we will be the kind of central repository for that information. And then, I mean, that will be relatively static information, but then it will give us the ability to do more accurate modelling, you know, based on certain information that's captured in that register. In terms of how many sides are we talking about, I'm not sure what that refers to. Stuart, are you?
The only thing I could think of there would be how many from visibility from multiple sources. I'm assuming.
Yeah, right. How we make that information available is a good question. I'd have to take that one on notice. We'll have to see. I'm not sure exactly what the answer to that one is. In terms of, I'll just jump in on this one. I think, yeah, we have had a look at what Germany has done, and you know, interestingly, the approach taken in Germany can probably be characterised by increasing investments in distribution networks, basically to enable everyone who has solar to be able to output pretty much all of that solar when the sun shines. There is curtailment that happens within the German market context, but usually it's large scale wind and solar that is curtailed, not small scale. They do have the ability through relatively old ripple control technology to do a certain percentage of the curtailment, but they rarely do that in the studies that we've seen. But I think what we're talking about here is a new approach to effectively try to optimise the solar and battery usage within the distribution network, so that you know, curtailment is required very rarely. So I guess that's one of the premise of this particular work.
Yep. And I'd like to reiterate the fact that we have done both previously through so this work was obviously informed through the transformational roadmap process, where we did a lot of work with international stakeholders, and we actually did a big scan of the work over there. Plus, we also had input from key experts from both the US, Europe, and the UK, and some other places as well. And then it's also been informed by some updates to that work that we've done. So AEMO's just done some another report actually to update some of that international scan to actually get some of that to inform this piece of work. And secondly, we've particularly through Energy Networks Australia, we've done a lot of work connecting with what's going on in the UK and actually sharing information between our process and theirs. So we've been sharing lots of things back and forth between the two projects, the project they've got over there with the open networks and ours, and that's going to continue to happen as well. The next question comes in and around the has ENA and AEMO considered that South Australia is not the same as other parts of the network? And the answer to that is yes. So obviously the issues in South Australia are very important and probably critical in terms of time critical in terms of how we solve and look at those. But there are other parts of the country which are facing similar issues. So obviously Southeast Queensland, and we've been doing quite a bit of work with some of the guys out of Energy Queensland and what's going on there. But also what's going on in Victoria, what's going on in New South Wales, etc., Western Australia, and actually drawing on that, but also looking at each of those different areas in terms of what their unique issues are as well. So it's not all the same. They're all facing slightly different issues or slightly different uptake rates, and how the networks are configured are different as well. So that is being considered and looked at, but we don't want to end up with a bespoke way of actually solving that. We want a system that actually can actually work together and actually so you end up with a similar approach to actually how we actually integrate and utilise that DER going forward. So AEMO doesn't have to work with 5 different systems. We've actually got things that actually they're interoperable, and we actually create that system that is interoperable across the systems, across the board. I was going to say what the next one's going down to. Network solutions suggest we have only considered the challenges and issues from DER, and what about the benefit stack? I think we got to that later on, is that there's a lot of value that can actually be provided by batteries. What we want to do is actually release that value. So yes, we need to identify what the challenges are so that we can actually get the best value out of that battery, that investment that we're going to utilise going forward in that area. So it's not to say that we want to stop this because there are challenges and issues. We want to say we want to solve those issues and challenges so we can actually release that value both to the customer who owns it, but also to the wider customer base out there to make sure that everyone's getting benefits from the system going forward. How can you manage residential batteries without affecting customers? I suppose the issue there is around that issue of control, and I suppose the issue there is going to be around incentives. So incentives for the customer to actually allow their batteries to actually be utilised at different times of the year. Now, that if it's going to be for system constraints, we're thinking yes, that may be required, but it may be at a very minimal requirement. So maybe at the worst, maybe once or twice a year, that will actually be needed to actually be utilised for managing those constraint issues. But the whole idea is that to actually potentially we're going to be investigating things like optimising it. So maybe an aggregator would come in and actually incentivise the customer to allow them to orchestrate when they can actually inject larger amounts of DER into the system at a price signal and things like that. So the whole idea is what we're trying to do is investigate how the best way to utilise that and what are the ways of actually delivering it going forward. Next questions were around that 1.4 million. Yes, that was a mistake. It was 1.4 billion. There was a whole lot of questions around the IEEE and 1547. Again, part of the work that comes from this and the work we're also doing separately with Standards Australia is to look at standards are going to be a huge issue. We do not want to create new standards for Australia. The whole idea is that we would like to actually adopt what's the best way of, and identifying the best way of adopting international standards in this area, so particularly around interoperability. And so there's some work going on in that space separately to this, so it's not part of this, but this will inform that piece of work, and anything that goes on there will come back into this. I am cognizant that we've just run over time. I could answer a few more questions, but the other choice is we take the rest, and I'm also aware that people have only got a certain amount of time available to actually be part of a webinar. What we'll endeavour to do is, there's a whole lot more questions that are actually sitting in this. We'll endeavour to try and, we've got those on, so we'll try and print those out, get access to those, and then try and answer those in a consolidated manner, and actually post that on that website where I was talking about earlier to go through. But also, if people want to talk to us individually or engage with us individually before that, again, please contact myself in the short term, in the initial term, and make sure that you're actually part of some of the workshops and web that we're going to have going forward. So once we announce those, please register for those, which is appropriate for yourself. And last but not least, please provide submissions at the end. The more information we get from people, the more we get, the better we can actually make sure that we actually cover all the different aspects and issues that we may need to look at or consider going forward. Anything you'd like to say, Chris, before we close off?
No, I think you've covered it off. Thank you, Stuart. Thanks everyone for listening in.
Yeah, and last but not least, I'll apologise again for some of the technical issues we had around the sound. Hopefully that wasn't too bad for people, but anyway, thanks very much for putting up with that. Thank you very much.